The 3 Atlas facility and the pulsed low-surface brightness spreads across the envelope surrounding the dense core of the plume at 3I Atlas. Careful measurements show that the glow around 3I Atlas extends roughly 2 resolution elements, which corresponds to about 2 pixels on high-precision detectors. This is apparent because background stars in the same frame appear as point sources with widths approximately half that of the glow surrounding 3I Atlas. Beneath the Franco-Swiss border, within the European Organization for Nuclear Research, an event of staggering scientific magnitude took place in the 3I Atlas facility. A concentrated pulse of light, so precise, so intense, and so meticulously controlled, was directed toward the Earth's atmosphere. The phenomenon was a deliberate, controlled experiment, not a weapon, not a cosmic accident, but a moment that blurred the boundary between human technological achievement and the vast forces of the cosmos. When the announcement came from the team of researchers, the scientific community, and indeed, the world, was electrified. The pulse, lasting only a few femtoks, contained a luminosity momentarily comparable to that of a small star compressed into a single, focused beam. It was an event years in the making, the culmination of decades of theoretical planning, engineering innovation, and relentless pursuit of understanding the most fundamental properties of light and energy. At its heart, the 3I Atlas project represents an unprecedented fusion of cutting-edge technology and theoretical physics. Its mission is to explore the thresholds of photonic energy and examine how it interacts with matter on the quantum scale. The acronym 3-2 refers to intensified interference interactions, describing the experiment's innovative approach of layering wave interference across multiple energetic channels to achieve an extraordinary effect. Atlas, already one of the world's most sophisticated particle detectors, was upgraded specifically for this experiment. The facility now houses ultra-intense laser arrays capable of generating unprecedented light densities, superconducting field stabilizers to maintain near-perfect coherence, and a temporal focusing chamber engineered to compress light into concentrations never before achieved. The experiment's objectives are ambitious: to probe photon cohesion, observe quantum vacuum fluctuations, and measure energy transitions between photonic and baryonic states. When the pulse was activated, sensors across the complex immediately detected a rapid and unprecedented rise in photonic pressure. This was no ordinary beam. It was structured in layers, like nested ripples of light, harmonized into a single, exquisitely directed emission. Observers at ground level described a brief but astonishing column of blue-white brilliance. The intensity of the light seemed to bend the surrounding air, momentarily distorting the sky above before vanishing into the atmosphere. The implications of this beam extend far beyond visual spectacle. Its energy density surpassed 1023 watts per square centimeter, reaching the theoretical threshold where light begins to exert measurable gravitational influence. For the first time in a controlled laboratory environment, photons behaved as if they had mass, interacting gravitationally with each other and the surrounding space. Inside the control chamber, banks of sensors, photomultipliers, and field monitors captured every fraction of a nanosecond. The data confirmed predictions. At sufficient energy densities, light could mimic matter's behavior, creating effects previously observed only in extreme cosmic phenomena. For a few trillionths of a second, Earth became the stage for a laboratory-created environment that simulated conditions present in the earliest moments of the universe. The experiment also serves as a testing ground for ambitious theoretical objectives. Scientists hope to unify gravity, electromagnetism, and the strong and weak nuclear forces within a single framework. By directing such an intense beam toward Earth, the researchers were able to observe interactions with the geomagnetic field, the ionosphere, and subatomic particles suspended in the atmosphere, offering invaluable data on how light behaves in gravitationally influenced fields. The firing of the pulse required meticulous orchestration. Supercooled superconductors stabilized the laser cavities at near absolute zero to eliminate the slightest vibrational disturbance. The pulse was synchronized with Earth's rotation, ensuring it passed through the least dense regions of the upper atmosphere. Even the planet's curvature was factored into the beam's trajectory. Satellites, high-altitude drones, and spaceborne detectors monitored the experiment, capturing quantum effects, atmospheric phenomena, and philosophical implications. One of the most fascinating outcomes was the beam's interaction with the quantum vacuum itself. According to quantum field theory, what we perceive as empty space is teeming with virtual particles that flicker in and out of existence. A sufficiently intense energy field can polarize this vacuum, temporarily converting virtual particles into real ones. The 3I Atlas team detected anomalous bursts of positron-electron pairs, confirming that the pulse had indeed triggered measurable quantum events, a remarkable macroscopic validation of vacuum polarization, previously observed only in astrophysical phenomena. As the beam propagated through the atmosphere, sensors recorded unique ionization patterns spanning kilometers. Air molecules excited by the high-frequency photons emitted secondary light in ultraviolet and infrared wavelengths. While the beam left no physical trace on the ground, it temporarily altered the ionosphere's charge balance, creating a faint, ethereal glow visible only to sensitive instruments. From orbit, it appeared as a rippling, ephemeral halo of light, an aurora created entirely by human-directed energy. The beam was far from static. It contained layered oscillating harmonics, allowing the researchers to encode data into the frequency spectrum, a technique called quantum photonic modulation. As it traveled, photon backscatter provided real-time feedback, turning the pulse into both messenger and message, simultaneously an instrument of observation and an object being observed. Under these extreme conditions, light behaved as a self-contained energy field capable of subtly modifying space-time curvature. Microlensing effects suggested that the energy density was sufficient to bend spacetime on a microscopic scale. This opens a realm of revolutionary possibilities, simulating conditions near black holes, testing the limits of the Standard Model, exploring photonic propulsion, quantum communications, and even planetary defense via directed energy. Beyond practical applications, the experiment carries profound philosophical significance. For centuries, light has symbolized knowledge, discovery, and enlightenment. Now, humanity has turned that metaphor into reality. Light itself becomes a tool to probe and shape the structure of existence. The beam's path revealed fractal-like spirals and harmonic structures, self-organizing under immense energy. Some theorists speculate these may represent luminal solitons, stable, structured packets of light, a new state of matter energy capable of persisting independently. The experiment also pushed material science into uncharted territory, utilizing mirrors made from layered graphene diamond composites, quantum-cooled reflectors suspended in magnetic vacuums, and metamaterial chambers capable of bending electromagnetic fields. For a fleeting moment, Earth became both observer and participant in a fundamental act of creation. The pulse interacted with matter, vacuum, and spacetime, offering a glimpse into the very architecture of reality. The experiment demonstrated that the universe is more interconnected than previously thought. Light, matter, and spacetime are layers of the same continuum, capable of influencing one another in ways now measurable. This is more than a technical achievement, it is a conversation with creation itself. The 3I Atlas pulse transformed understanding, showing that controlled light can both probe and recreate the fundamental interactions of the universe. It hints at future possibilities, manipulating vacuum states, harnessing zero-point energy,